Ever wondered if you could hop into a time machine, visit the past or future, and alter the course of history? The concept of time travel has long captured our collective imagination. It's a staple in popular culture, from H.G. Wells' groundbreaking novel, The Time Machine, to the time-twisting antics of Doctor Who. Why are we so fascinated? Perhaps it's the allure of rewriting our past mistakes, or the tantalizing prospect of peeking into the future. Imagine, for instance, witnessing the signing of the Declaration of Independence, or getting a glimpse of what technology will look like 100 years from now. It's these scenarios that make time travel such an enticing idea. But is it merely a figment of our imagination? A fascinating plot device confined to the realm of science fiction? Or could there be a scientific basis for it? So, is time travel just the stuff of science fiction, or could it actually be possible? Let's delve into the science. Einstein's theories of relativity gave us the first serious scientific basis for time travel. When we think of Albert Einstein, we often picture E=mc squared, or energy equals mass times the speed of light squared. But this genius mind also brought us two game-changing theories of relativity: special and general. Let's start with Einstein's special theory of relativity. In simple terms, this theory tells us that the laws of physics are the same for all non-accelerating observers, and that the speed of light is the same no matter the speed at which the observer is moving. This introduces the concept of time dilation, where time can appear to move slower or faster depending on one's speed or gravitational field. Think of it like a cosmic speed limit, a limit that when approached can stretch and distort time. Now, let's move on to Einstein's general theory of relativity. This theory extends the special theory to include gravity. It describes gravity not as a force but as a curvature of space and time caused by mass and energy. Imagine a bowling ball placed on a trampoline. The ball will cause the trampoline to curve or dip down. This is similar to how mass and energy distort space-time. But how does this relate to time travel? Well, both theories suggest the possibility of wormholes. These are essentially shortcuts through space-time that could, theoretically, allow us to travel vast distances in an instant, or even travel through time. Imagine a piece of paper. If you wanted to get from one end to the other, the quickest way wouldn't be to move across the surface, but to fold the paper so that the two ends meet. That's the basic idea behind a wormhole. However, creating or finding a stable wormhole, let alone traveling through it, remains a colossal challenge. And even if we could, these shortcuts through space-time might lead to some perplexing paradoxes. While Einstein's theories suggest time travel might be possible, they also present some mind-bending paradoxes. Imagine going back in time and doing something that prevents your own birth. This is the famous grandfather paradox. The grandfather paradox presents a fascinating conundrum in the realm of time travel. The name stems from a hypothetical scenario where a time traveler goes back in time and accidentally or intentionally causes the death of his or her grandfather before the birth of their parent, which in turn would prevent the time traveler's own birth. Herein lies the paradox. If the time traveler was never born, how could they have traveled back in time to kill their grandfather? It's a conundrum that challenges our understanding of cause and effect. In our everyday life, we're accustomed to cause preceding effect. You press a switch, a light turns on. But with the grandfather paradox, the effect, the time traveler's existence, seemingly precedes its cause, the grandfather's survival to father the next generation. The paradox shakes the very foundation of our understanding of time. It suggests that time may not be a simple linear progression from past to future, but something far more complex. Some theories propose a self-consistency principle, where the sequence of events would always adjust itself to avoid any paradox. In the case of our time traveler, something would always prevent the grandfather's death. Others suggest the concept of multiple universes or parallel timelines. If the time traveler did kill their grandfather, they'd merely create a new timeline or universe where they don't exist, while their original timeline remains unchanged. The grandfather paradox isn't just a mind-bending thought experiment. It's a profound question about the nature of the universe, the flow of time, and the very fabric of reality itself. It's a question that science is still grappling with, a question that continues to fuel debates and inspire explorations. Paradoxes like this one make time travel a complex and controversial topic. But what if time travel has already occurred? Over the years, there have been some intriguing claims of time travel. Let's take a short trip down memory lane. One of the most famous is the case of John Titor, a self-proclaimed time traveler from the year 2036, who surfaced online in the early 2000s. He made some bold predictions, many of which, interestingly, have not come to pass. Another curious case is that of the time-traveling hipster, a figure in a 1940s photo who appears to be wearing modern attire. Skeptics, however, have debunked this, pointing out that all the items he's wearing were available at the time. And who can forget the tale of Rudolph Fentz, a man who allegedly vanished in the 1800s only to reappear in the 1950s. Yet again, investigations have suggested this story is likely a work of fiction. While these stories are fascinating, they remind us to approach the topic of time travel with a healthy dose of skepticism. But let's imagine for a moment, what if time travel were indeed possible? The implications are profound, aren't they? Changing the past could drastically alter the present, potentially erasing events, people, even entire civilizations. Imagine visiting the future, only to return with knowledge that could shift the course of human history. And there are ethical considerations to ponder as well. Would it be right to meddle with the past or peek into the future? Who would get to decide what changes are made? What safeguards would we need to prevent misuse of such a powerful capability? But beyond the practical and ethical concerns, time travel also invites us to reflect on the nature of reality itself. It encourages us to question our understanding of time, causality, and the very fabric of our universe. Time travel is a captivating concept that continues